line. Doon ay mga kuan, mga objects sa inside sa mga industry nga ang iyang trabaho like for example kanang mga robotic arm, kanang tigtaod sa mga tigdukduk sa mga kuan. So sometimes dili na tao magbuhat na robotic arm na sila, no. So ang iyang program na mo gito yung trabaho, no. So kung iyang trabaho tigtaod lang sa amin sa sakyanan, so ang iyang trabaho is mukuha siya sa amin, i-plaster din niya, move ang arm, adto din dito siya sa car, mo pa sa amin iya din iduot dito, no, precisely, no. So then the car kanay sa amin move, mudagan sa lain bag-o nga car mo pa sa amin, bali na sad siya dito, kuha din. So mo gid ang trabaho, tigtaod din siya. So mao na siya ang mga usa sa mga kuan sa mga dynamics, no, kanang putos sa mga kuan, let's say naman daghan ato dinhi, no, sa mga factory, like for example musud ka sa Nestle, kasi daghan mga robots diya, no. Ang una lang ang mga robots kini tig kahon sa mga cook, no. Ang cook nga gadagan pag abot sa ganing mga bottle. So pag abot sa end, so siya na yung mabutang sa kahon, no. Robots na, dili na tao, no. So kuan yan na tigtaklob sa botilya, no. Ang botilya nagdagan no kay sunod, pag abot sa unahan nanay sunod, ya pag abot sa unahan doon na siya ay taklob, ya mudagan sa dyan dito para musulod sa mga case singana. So kita sa kung kanang mga factory sa gatas, no. So mo mga coffee production, saan nila pagpack, saan pagluto, ana. So ang uban nga mga kuanda na dili na manual, no, o dili done by robots, no. Doon na yung mga robots, no. So ang iyang mga movement ato mag-graph ni mo actually. Bisan kining mga train moving from let's say from one station to other station. So dili na ditso ang train mo kusog dagan, no. From zero velocity hinay pa na siya, hinay. Ya mo kusog dayon, doon na kay gitawag nga kung aeroplano pa na siya, take off speed, then doon na kay kanang dito na sa taas, no, kanang uniform speed na niya. Up doon na gali ka sa airport, nindo mo nga medyo doon na siya ay paghinay, no, pagkuhan. That is what they call nga mo descent na siya, no. So you have tulo siya ka stage, no. Kada paglupad o kanang middle kuan niya, middle flight, then din siya landing, no, pag-landing na niya. So so kung i-graph ni mo na siya, lahi ang velocity sa pag-take off, lahi sa dang velocity sa mid-flight, lahi sa dang ang itong final nga part sa trip nimo, no. So mag-graph ni mo na siya. Okay. Now I will present another example which I am going to solve by Excel because it is somewhat shorter. Okay, we have here a problem of a ball, no. So see here that the ball is tossed vertically. So let us assume that the ball travels vertically, wala siya gihuyop sa hangin nga napalit siya sideways. So let us say nga walay hangin, no. Tossed vertically, once it reaches maximum height, it will go down vertically, no. Go down vertically and hitting the ground. The problem is that the ball is tossed from a window 20 meters above the ground. So siguro siya sa mga 5 to 6 story, no. So 6 story niya tag 3 meters kapin, so nasa 20 meters, no. So gitoss niya ang ball up, now giving it initial velocity, kaya ang ball dili mo gina siya mo musaka unless imo siya tagaan og initial velocity. Kung buhian na nimo ang ball without tossing it, the ball will slowly drop. Dili siya musaka. So para musaka ang bula, gitagaan yang gihatagan og tawag ani initial velocity, no, of 10 meter per second upward. Okay? 10 meter per second upward. But due to the action of gravity, ay ma-feel na to nga ang ball mo hinahinay gid siya saka, no. Pero mo hinahinay siya hangtod ka mahulog. Okay? Pag hulong sa taas, dili sa na siya pundo dito. hinihinay na sana siya paubos, antong nga, mukusog siya, no? Okay? So, in fact, pag dapat niya sa yuta, which is 20 meters below from the hand of the individual that tossed the ball, mas kusog na ang iyang velocity, no? Mas kusog sa 10 meters per second. Now, that is the picture that I can show it to you from the problem. Okay? So, a ball tossed with 10 meters per second vertical velocity from window 20 meters above ground. Okay? Kung sa may makuha na to, ani, that means nga, kung atong himuon nga reference ang ground, ang y ni mo nga initial, or y1, or yi, but I will use y1, is positive 20. And then my b1 is 10 meters per second. Okay? If you are going to make your hand, the hand of the individual that tossed the ball as the reference, then your y sub 1 is 0 and your b1 is still 10 meters per second. So, actually, since reference system is somewhat arbitrary, you can choose, no? You can choose. Okay. Now, the problem is we have to determine the velocity and elevation above ground at time t. So, meaning we are going to determine the equation as a function of time. Okay? And that's good because if you have equation of velocity and elevation, now, if you can still derive the velocity as a function of time, with respect to time, you will have an acceleration. You can have a graph, and then that is good for Excel, no? For a spreadsheet. Okay? So that is what we are going to do, no? And then from it, if you can graph, you can determine the highest elevation reached by the ball because graph will tell you. And then the time also when the ball when y is equals to 0. Okay? So that's it. Okay, so I am going to solve this using Excel. Okay? So may tabo dani niya. Okay, magugol ko. So, ang hitabuan niya, kung himuon na to ang ground as reference, so we will have y1 is equals to positive 20 meters. Okay? And then we have also v1 equals to positive 10 meter per second. Okay? 10 meter per second. Okay? So, ang unang given lang given ani is velocity, no? So, we have v or equals to dy dt is equals to 10. Okay? dy dt is equals to 10. Okay? Now, dy dt is equals to v. So, we can have dy equals to v dt. Okay? So, that is an equation. dy is equals to v dt. Okay? If we are going to say differentiate integrate dy, it will become 1. Okay? And then you will have differentiate b dt. This will become bt, no? B times t plus constant of integration. Okay? So you will have y plus pt plus c. Okay? Now the constant of integration will be solved by inserting known values. We know that at time 0, okay, the known values is that at time 0, y is equals to 20. So what or okay, y equals to 20. So 20 is equals to 0 plus c. So c is equals to 20. So that means that your equation y equals to 20 plus b. That is y as a function of time. Okay? And then, you know also that okay. So, it's like this, no? Acceleration, we start with acceleration. No? Acceleration is equals to, we know acceleration is not given in the problem, okay? But, bisag wala tayo giingnan nga, wala acceleration there. So, kung mo siya ka na object pulling ba? It's a pulling object. So, it is subjected to gravity. So, acceleration there, whatever time it is always present. So, the acceleration there is equals to negative 9.81. Okay, taking it as the gravity. Why you use negative? Because we use positive as going up, and then gravity is going down, so it is opposing the positive axis that we have. That's why we use negative. So at first, this is what happened. No, using this problem. Okay, I will stop sharing this document, and I will move to Excel. No, to spreadsheet. Okay, so I will go to the spreadsheet nga kuan application. Solve na to window, and then sa ito ha, this one. Okay, share. Doon na pa yung sulod isa. Is equal to acceleration, in which is equal to negative 1.0. Plus, I have told you that this is negative because our y is going up. No, our y is going up. And we take the y-axis at the ground. So, meaning the ball is drop at y equals to 20. That is the initial height. With an initial speed of positive 10 meter per second. Okay. So, acceleration is 9.81. This is not given, but it's there. No? Okay. That's not a trick, but it's there. No, it's fact. Then dv dt equals to acceleration, you have 9.81, and then if you derive dv with respect to time, you will have 9.81 t plus constant of integration. Now at time t equals to 0, v equals to 10, so that's why c equals to 10. So your equation now, instead of having c, it's now replaced by 10 meter per second. Okay, 10 is the initial velocity at time equals to 0. So v equals to 10 minus 9.81 t. Okay, that's it. You have an acceleration, you have a v. Okay. Now, you will know also that dy dt, okay, dy dt, you know also that dy dt, dy dt is equal to velocity. Okay, you have here dy dt, dt is equal to velocity, which is 10 minus 9.81 t. Okay. Now, if we are going to integrate dy, or we multiply the right-hand equation, no, all the terms in the right-hand equation by dt, and on the left-hand equation by dt, so you will have dy minus parenthesis 10 9.81 t plus parenthesis dt. If we integrate dy and dt for the other side, I will have an equation equal to y minus 10 t minus 1/2, no, 1/2 or 0.5. I will see 1/2. Ako na butang 1/2. 1/2 9.81. Parenthesis na lang, 9.81. Then your t has a power of 2. Power of 2. Okay? Then you have a constant of integration c. So how are you going to solve for c? You just multiply, you just say that at time equals to 0, y equals to 20. No? Initial velocity. So your equation then will become y as a function of time is equal to 20 plus 20 minus you have 9.81 over 2, then you will have t power of power of 2. So, okay, this is the second equation. I'm going to put it here. Malaki yung ang bago. Okay, that nag-iwan ko nga ang dy dt ay equals to v. No, v. Ang v, mauna siyang 10 minus 9.81. Kanya kung akong ibalhin ang dt to the other side of the equation, may i-integrate na ako kaisa, I will have the integrate 1 as y equals to 10t minus 1 half 9.81 t squared plus c. Solving for c, that at y equals time equals to 0, y is at positive 20, so I have this equation. Okay, so I can use this equation, y equals to 20 plus 10t minus 9.81 t squared over 2, and v equals to 10 minus 9.81 t, and t equals to 9.81 to solve for b. For the problem, the highest elevation reached by the ball and the time when the ball hit the ground. Okay. Okay, so I have the required equation here. Okay. So, ang buhaton na ko karon, okay, is magbuhat ko og time. Mo siya ang time. Time, seconds, then buhat ko og y function of meter. Okay, so I will graph the y against time using this one. Velocity lang sa velocity una, no, velocity sa unahon nalagi y na lang sa y. Okay, then I have here 0. Then ang equation mo sa y will be doon na kay 20 positive, then na kay plus 10 times time, which is E17 at this time, E17, and nalagay ko yung 9.5, which is 1 half, na may 1 half ito nga kuan, na term, times 9.81, times E17, kaduhaon mo na siya kay squared man. Okay. So, balik ng 20 plus 10 times E17 minus 0.5 times 9.81 times E17 times E17. Mao na siya ang equation sa y here. No? So, at time 0, 20 gid ang y. No? Meaning, wala pa gid ni lakaw ang bula sa iyang kamot. No? Okay. Time 0 man. Okay. Now, I am going to copy this. Copy. And then paste that at the bottom as kuan. Ay, butang sila kong time dahil. Kapag ako ma-define ang time. So, ako sila yung ano, no? So, doon ako plus E17 plus pala 2.1. 2.1. So, na 0.1. And then, kopyahon ako na siya. Copy. Pwede siya natulog ito. Yan ang taman, no? Paste. So, ang time na ko, gagmay kahit 0.1 ang kuan. Ang yung interval. 0.1, 0.2, 0.3, 0.4, abot sa 1. Yeah. Abot ko nga rin no? You can extend that as much as you can, no? Then, abot siya o 12, no? Abot siya 12. Okay? Next ang buhaton is, ako sa siyang i-box. Ako sa i-box. Kaya yun. Okay. Then, okay. Then, na-define naman ako ang equation sa y. Based sa equation nga niya din, yung niya. So, mo naman siya. Ako na lang na siya kopyahon. Yan, ako siya i-paste. Kita na to siya gawin kung asa siya ang y min 0. Paste. Okay, so kita na to nga ang y increase yung height. I-increase siya. Pero tama na sad siya diya sa 1.9 second pag 2 seconds wala na niubos na siya balik, no? So, ang maximum din naabot niya is 25, no? 25,095. Ito na yung pinaka-last niya. Yan. Nahulong na po din siya. Nahulong, gamay na din ang one. So, maximum niya is at 1 seconds. Then, na-out siya. So, tama na siya din. Tama na siya sa 3 kapin. No? Hindi na siya tama. Tupin siya. Ito na din yung reason. Cut. Or clear. Clear content. Okay. Okay. Ako na siyang i-reason kung ano man. Di nakabot 3.3, no? So, pag muna ako na siyang i-graph, i-graph na ako na siya. Mao ni siya ang y. Y versus time. So, na siya sa 3 kapin, no? Na diha 3 kapin. Okay? Saan ka na ito siya pag-determine? So, ito gina siya i-determine. No? I-determine na nato na siya. But, mabutangan natin yung sakto on time kaon ani no? By solving the equation here. Okay? Kuan man ni siya. Kung imo na siya sulbon, quadratic ni siya. Kung kano saan man ang time nga mahimo siyang zero, no? Okay. Munang ang the highest elevation reached by the ball is you can determine that sa velocity, no? Sa velocity. So, kung mao ng velocity atong kopyahon ni siya, maka-plot ng velocity. Kano sa man ang velocity mo stop. Mao na siya ang kuan. Mo stop going up. So, kini siya mo na to siya ang velocity. Velocity niya. Ang unit niya na meter per second. Okay? Dini, reason na nato siya. Ang velocity kini ng plus 10 minus 9.81 times D17. Okay? 10 times 9.81 D17 represents the time here. No? So that's it. So 10. And then we expect na ang velocity mo hinahinay siya, ang value niya, kaya tungod sa action sa gravity. So, ato na siyang makita karon din. Okay, so, nanihinay yun. At 0.1 seconds, himo na lang siyang 9.0119. Sa 0.2 seconds, himo siyang 8.038. So, taganap gada ko ang time, taganap sa kahinay ang velocity going up. Tama nga ni stops, ni hapit siya ni hunong sa 1. So, nasa 1 point kapin ang time nga ni hunong siya. No? So, mo na siya. Now, with respect to acceleration, 9.21, so 9.21 naging siya tanan, no? Anyway, velocity of time mo may gipakita, no? Pero kung gusto ka og acceleration, ako sa na-graph, ha? Graph sa ako na siya. Insert graph. Okay, so muna siya ang velocity versus time. Okay? Makita niyo mo din unsa ang velocity against time, no? So, ang pinakakusog ng velocity, kanag yung pag-toss na sa ball. The moment the ball travels up, hinahinay na siya. Tama nga, at 1 second kapin, nihunong siya, no? O ba tagabalaw pili kapin, ato na masugkal. Okay. Now, kung sulbon sa nimong acceleration, klaro naman kayo nga, 21 lang siya, wala siya, ano, so, for the purpose of solving, solve naman nato for the purpose of showing, pwede natin na siya ngayon. Okay. So, na siya ay acceleration meter per second squared. Squared na siya. Okay. So, na siya. Then this one, minus 9.1. And it's not a function of time actually. So, bisan pagpilay time, ano niya, 21 na din na siya. Okay. Graph. So, kung ato siya i-graph, acceleration, para lang di makita na to, insert, graph, tawan. So, kita na to nga, ang acceleration mo ni. Acceleration. Acceleration versus, okay. So, you see that it's 1.9 always. Now, let us solve for the problem highest elevation reached by the ball. Dili makuha na to, tawag na to, mabadabana na to, 3.2 kapin, doon sa sinabot ng 2.3. Kay, kana man ang mahimong zero ang value sa y. So, we can solve it by this equation, no? So, solving that equation, mahimo na siyang, what is 1/2 of 9.81? 4.905 t squared. Okay? Then doon na kaya minus 10t, ako lang i-change ang kuan ang sign, minus 20 is equal to 0. O na siya, is equal to 0. Okay? Doon ka value sa time niya, quadratic. Ang isa, imaginary, kung ang isa, dili. No? So, yan. So, akong kuha ng answer, answer ba ito eh? Okay, so, so 3.28 second ang answer, oh. 3. Ano ka buk answer ano niya, no? So, ako i-paste din eh. Mo ni siya ang answer niya, no? From this equation, kung imo yung isit ang y equals to 0, ang time duha ka buok. Time negative 1.243 seconds. So, kung negative ang time, ba't may wala pa nag-exist, no? Yung isa, 3.28. So, ang 3.28 nga na din eh. 3.28. So, kung ato ni siyang singitan din eh og 3.28, no? Din eh. Kung singit ko diha, ubutang ko insert ko. So, nakoy 3 niya. Ako na ibutang ang 3.28. 3.28. Okay. Wala siya answer. Kaya nga nun, wala ba ito gipupya. Nako na siya ako. Ako na i-face niya. Pagin, no? So, ground off ni siya, no? Ground off. Okay. So, practically na yung answer, no? No? Na yung answer. 3.28 kapin. Okay. So, masolve niyo mo na using quadratic. So, kung i-quadratic niyo mo na siya, ang A equals to 4.905, ang B equals to negative 10, ang C line equals to negative 20. So, the formula actually is we will have B squared ito minus B plus minus square root of B squared minus 4 is divided by 2. O ba na siya? Divided by 2, so ayan. Plus minus square root of 100 plus 4 times 495 times 20. So, pasa ko calculator, guys. Plus 4 times 4.5 times 20. So, ang answer is taas kayo, no? 3.28135. So, ang answer is 1. Sa time nga kuan, time equals to 3.28125. 28135 ay 354524 seconds. Kinanglan. Ni abot ang kuan ang bula sa ground. Okay? Muna siya ang answer dani no highest elevation time that the ball hit the ground. So pila sa dang velocity niya na, no? Kung ako na siya substitute din 3.3281 354 81354 524 katawa na to ang iyang height. 3.28
sir. 3.3.
3.2, sir.
28 dahil 28. Ay, 28 dahil 28. Okay, nakuha mo ani. So, ito mo kayo, 3.28 na. 3.28. Oo, kamay kayo. So, pagkalidero na. Yeah, kung mauni siya ang atong kopyahon, butang natin ini. Paste. Yeah, kopyahon na to. Velocity mo siya. Pila velocity niya, pagdangpak. Copy. Paste. So, it has a velocity of negative 22.19. Negative means that velocity is going down. Okay? Not going up. Okay? So, mauna siya ang velocity. So, negative 22.2 pero 19 na siya. No? So, we answered already actually the last problem. The highest elevation reached by the ball. Okay, that's when the ball equal to 0. So, when B is equal to 0, meaning it stop going up na. Kani 0 na gid siya. Sulod ni button is go down na siya. So, from the equation of B equals to 10 minus 9.81. So, T is equal to 10 divided by 9.81. No? And that is equals to positive 10 divided by 9.81. So, you will have, that's the time, no? The time that the ball reaches the maximum height. So, if we are going to substitute that here, time equals to 1.19. So maybe we will insert here. No, I will insert arrow. Okay. So the answer is that one. I will copy that. Copy. Post that here. Paste. Value only. Paste. Value only. Okay. So, but I will copy this. Copy and paste. So, the maximum height is 25.096 Okay. And but about the velocity, so if I'm going to copy that, copy and then paste 0. Okay. So you already answered it by just using graphical, no? Because you can see it from the graphics. Maximum is 1. Pwede ulit paklaro kayo. So how to, kung imo siya klarohon, gamitan yun yung equation. Okay. But this is already a good estimate, no? Like for example, the y against time, no? The y against time. This is the value of y against time. Okay? Maximum height niya is 25. Yeah. At time nga nahimong y equals to 0 is as just at 3.281 seconds. Okay? With a velocity of negative 20 kapin dito. Okay. So that's how I solve the problem using this one. No? Okay. So I will stop sharing this one. And then, okay. So, ang sunod akong buhatong class is maghatag ko og assignment sa inyo para payhad to. Okay. Okay, solve ako lain problem, no? Solve po to na ako to na. Kaya doon naman to siya kuan kanang follow-up problem before I will give assignment. Okay, follow-up problem is yeah, this one. Okay. Okay. Okay, I hope may gawas na sa inyo yung kuan. Okay. Now, kung sa'yo may tabo kung ang ball is pushed downward, no? Pushed downward. Okay? So, this one will be your assignment, your assignment. Your assignment. Okay? And then, maybe we will solve a problem in projectile for linear motion. That is, linear motion. Linear motion can be easily done by graphics, no? Especially if you can express them into function. Okay, so para di bagansi atong time, kusog ko sa linear motion. Projectile, okay? I have not problem sa projectile, so I'll check the problem with projectile sa internet and then I will share it with you. Okay, so nakuman na nita. Kini siya assignment niya, assignment 1. I will give 2 assignment. Actually, wala pa na ako ma-determine ng isa. Ang isa will be similar to the third example, no? Second example pa man eh. Okay? So, muna siya ang inyong i-graph sunod, no? Okay, so, mangita ako problem sa internet. Curvilinear, bahin sa curvilinear.